First of all, I welcome all the students and the participants who are attending this live lecture. Now see this, today in this live lecture we shall discuss the conservation theorem for total angular momentum. See this, we shall discuss the conservation theorem for total angular momentum. In the last lecture, we have seen that the conservation theorem of a linear momentum of a system. Here we shall discuss the conservation theorem for the total angular momentum of a system. Okay. किरण जाधव, राजमाने अनिता, पूजा आटोळकर, नवीद खान, अरे लवकर वेळेवर जॉईन व्हायचं रे, उशिरा यायचं नाही. प्रतीक्षा पवार, सारिका देशमुख. Now here we shall discuss this theorem, conservation theorem on, this is the part of a mechanics of a system of a particle. So in the last lecture we have seen that the mechanics of a particle means, consider system of a particle. System of a particle means it is a rigid body. You know that rigid body means it is the system of a particle. So we have seen this external force, internal force, and F bar is equals to internal force on a particle external force on a particle, and internal force, summation of all other forces, internal forces of a particle on I. We have already seen this. Okay. Now we shall discuss the theorem based on this. What is that theorem? Conservation theorem of, write down, conservation theorem of total angular momentum. Conservation theorem of total angular momentum. See this, okay. Now we shall write the statement of this theorem. What is the statement of this theorem? Statement. Statement of this theorem. हाँ लक्षात घ्या रे. 1 minute. जे काय मी आता विद्यार्थ्याची आज मी सांगेल तेव्हा प्रेझेंटी द्यायचं सर्व विद्यार्थ्यांनी. परत एकदा मी स्क्रीनशॉट घेणार आहे, कारण तेवढ्याच विद्यार्थ्याची प्रेझेंटी कन्सिडर केली जाईल. कारण आपल्याकडे 80 विद्यार्थी आहेत. 80 ला 80 विद्यार्थ्यांनी क्लास केलाच पाहिजे जर तुम्हाला परीक्षेला बसायचं असेल तर, नाहीतर तुम्हाला परीक्षेला बसू दिलं जाणार नाही. स्टेटमेंट. इफ द अप्लाइड torque is 0, then total angular momentum. What is the statement of this problem here? If applied torque is 0, then the total angular momentum is constant. This is the statement of the theorem. Or we can write, or see this. The angular momentum, prove that the angular momentum L bar is constant if the total external torque Ne bar is 0. We have to prove this theorem. If the applied torque is 0, then we have to prove the angular momentum is constant. That means the angular momentum L bar is a constant if the total external torque Ne bar is constant. Okay. Now same process we have to consider here. Suppose this is a rigid body. This is x-axis. This is a y-axis. So we can write this. Suppose this is a particle P whose mass is Mi. This is a particle Q whose mass is Mj, same. And this is a general particle, suppose, whose mass is small m. And at the centroid, the mass of that system is concentrated, so it is called as a capital M. Okay. Now see, this Ri bar means position vector of a particle P with respect to O. Rj bar means position vector of a particle Q with respect to O, and suppose R bar is a position vector of a general particle. As like yesterday's theorem, we have to prove this. Okay. सेम कालच्या थेरम प्रमाणे आपल्याला प्रूव्ह करायचं आहे. नाव कन्सिडर, आता मी स्लोली प्रूव्ह करतो, काय अडचण आली तर विचारत चला. Consider the system of particles having system of n particles, ठीक है, having masses small m1, m2, m3 dot 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 mi, mj dot 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 mn. Means there are n number of particles in that system. The masses of each particle is considered as m1, m2, m3 dot dot mi, comma mj, mn. Let Ri bar be the position vector of a particle P whose mass is mi, and Rj bar is the position vector of a particle Q whose mass is mj. See this. Okay. Now we know that according to the definition of the angular momentum, कोण सांगता रे definition? सूरज साळुंके, लवकर जॉइन व्हायचा, मोनिका गोरळे, वैभवी पवार, सुजाता. Now you tell me what is the definition of the angular momentum. We know that the angular momentum of a particle is the moment of a momentum. Angular momentum means the moment of a momentum. We know that the angular momentum of a particle is is the moment of a momentum बराबर आहे का रे स्टूडेंट्स, मोमेंट ऑफ अ मोमेंटम. सो द अँग्युलर मोमेंटम of the system of a particle is the cross product of Ri bar and Pi bar. मोमेंटम आणि Ri चा क्रॉस प्रोडक्ट घ्या, that is moment of momentum. So we can write, therefore we have the angular momentum is equals to which is equals to summation over I Ri bar cross Pi bar. Therefore, if we consider angular momentum, that is L bar is equals to summation over I Ri cross Pi. You know that Pi means the momentum, linear, it is a linear momentum. Suppose लिनियर मोमेंटमचा आर बार सोबत जेव्हा आपण क्रॉस प्रोडक्ट घेतो, सपोज दिस इज आर बार and particle is in the linear momentum, then the cross product of r bar and p bar which gives angular momentum. So the angular momentum of a system is given by L bar is equals to summation over j Ri cross Pj. We know that P bar means linear momentum चा काय फॉर्म्युला असतो रे? The formula for the P bar is mass into velocity. So हाँ चला रे स्टुडंट्स, मला सर्वांनी आन्सर सांगायचे आहे. P bar means linear momentum. linear momentum चा फॉर्म्युला काय? Summation over Ri bar cross m into Vi bar. V bar means the velocity of ith particle. Velocity of ith particle. So see, this m is the constant quantity, so we can take this out of the cross product. So summation over I m into, or we can also write mi. Mi means mass of ith particle. Ri cross Vi. Okay, so we can write this Ri cross Vi. Now if we differentiate this with respect to t, I shall write this again. So L is equals to, L bar is equals to summation over I mi into Ri cross Vi. Suppose this is equation number 1. Now differentiate this equation 1 with respect to t. So we can write dl bar by dt, which is equals to summation over I, mi is the constant quantity, d by dt of Ri cross Vi. So use the product rule. आता इथं डेरिव्हेटिव्हचा प्रोडक्ट रूल यूज करा. What is the product rule of derivative? So summation over I mi into, use the product rule, derivative's product rule of derivative of first second is it is dr bar I by dt, second is it is vi plus derivative of first second is it is, आता first is it is derivative of second dvi bar by dt. बरोबर आहे का रे स्टुडंट्स? पहा, this is the product rule of the derivative. So we can write summation over I mi into, देखो अभी dv dr bar by dt, you know that v bar is equals to dr bar by dt. So vi bar is equals to dri by dt. So we can write vi cross vi plus ri bar cross dvi by bar dot dvi bar by dt. Okay, so we can write L dot, we can write this as a L bar dot, L bar dot, L bar dot. काही जर कुठं नाही समजलं तर विचारा रे, लक्षात ठेवा. काही जर अडचण आली, कुठेही काही अडचण आली तर विचारा. नाउ यू नो दॅट द क्रॉस प्रोडक्ट ऑफ सेल्फ वेक्टर इज 0. दॅट मीन्स ए बार क्रॉस ए बार इज इक्वल्स टू 0. In this way we can take the cross product of vi bar cross vi bar is 0. So summation over I mi 0 plus ri bar cross dvi bar by dt. Here since you vi cross vi which is equals to 0. Okay, so we got next result is that, आता याला आपण असं लिहू शकतो, that is L bar dot is equals to summation over I mi into ri cross dvi by dt. So we can write this as summation over I ri cross d by dt of m हा कॉन्स्टंट कोइफिशिएंट आहे, मध्ये घेऊन लिहा mi into vi bar mass into velocity. See this, mass into velocity means linear momentum. So we can write this as pi bar summation over I ri bar cross d by dt of pi bar. So this can be written as a summation over I ri bar cross p bar dot ri bar cross p bar dot. In this way we get the relation L bar dot is equals to summation over I, we can write ri bar cross pi bar dot. Suppose this is equation number 2. Now we know that yesterday we have seen that pi bar dot which is equals to fi bar dot then we know that, see this, by the Newton's second law, we know that by the Newton's second law, yesterday we have seen Pi bar dot is equals to Fi bar external plus summation over j Fji bar. Okay. Put this value in equation. Put this value in equation 2. आता ही व्हॅल्यू जर इक्वेशन 2 मध्ये ठेवलात तर कशी टर्म येते पहा. परत रिप्लेस दिस पी आय बार डॉट, सो वी गेट एल बार डॉट विच इज इक्वल्स टू, आता इथं समेशन ओव्हर आय आर आय बार क्रॉस पी आय बार मीन्स एफ आय बार एक्सटर्नल प्लस समेशन ओव्हर जे एफ जे आय बार. Okay, put this value p bar dot. Now we can take the summation over I in the bracket, then we know that, now multiply this cross product, so we get multiply summation over I Ri bar cross Fi external plus summation over I summation over j Ri bar cross Fji bar. So we can write this summation over I Ri bar cross Fi external bar plus summation over Ij. How we can write this? Ri cross Fji. See this, suppose this is equation number 3, L bar dot. Yesterday we have seen that the summation over Fij, Fji, that is internal forces exert on ith particle by the jth particle and jth particle by the ith particle is 0. That means the second term of this equation 3, second term of this equation 3 becomes 0. We know that by the Newton's third law. By the Newton's third law, we know that the second term becomes 0. So, by the Newton's third law, the second term of equation 3 becomes 0. That is summation over I comma j Ri bar cross Fji, which is equals to 0. Put in 3. So we get L bar dot which is equals to, now second factor goes to 0. काल आपण प्रूव्ह केलेलं आहे. Internal forces of one particle to other particle to first particle of the rigid body is always 0. जर rigid body असेल तर त्या rigid body मध्ये internal forces एकमेकांवरचे काय असतात, 0 असतात. So the second part becomes 0, then remaining term is L bar dot is equals to summation over I R bar cross F bar E cap. Okay. Now see this is the formula we get. Suppose that formula is, simplified formula is considered as equation number 4. Okay, now we know that the torque on the system of a particle is, we know that applied torque on the system of a particle we know that the applied torque on the system of a particle is given by, applied torque on the system of a particle is given by or denoted by Ne bar, and which is given by Ne bar is equals to N. N means torque, applied torque. E means external torque, which is given by summation over, suppose I Ri cross Ri bar cross Fe bar. This is the formula for the torque. Suppose this is equation number 5. From equation 5 is the, see this, equation 5 is L bar dot which is equals to summation of over I Ri cross Fi external. But we know that the applied torque on a system of a particle, which is denoted by N bar, external torque E. So N bar external is equals to summation over Ri cross Fi E bar. So from 5 and 6, 4 and 5, from equations 4 and 5, we can write, how we can write, L bar dot E is equals to, right side same आहे म्हणून left side same येते, N bar external. Okay, so this can be written as dl bar by dt, which is equals to Ne bar. L bar dot means dr by dt, means Ne bar. Given that, suppose this is a 6, but according to the statement of the theorem, if the applied torque is 0, if the external torque is 0, given by the, given that in the theorem the external torque is 0, that is Ne bar, which is equals to 0. Put in 6, external torque 0 है, so we can write dl bar by dt, which is equals to 0. आता L चा डेरिव्हेटिव्ह with respect to t जर 0 असेल, see this, we have given, परत एकदा पहा, if applied torque or external torque is 0, then we have to prove that angular momentum is constant, means L bar constant. So खूप मोठा थेरम आहे, खूप महत्वाचा थेरम आहे. सो इफ डेरिव्हेटिव्ह इज 0, डेरिव्हेटिव्ह कधी 0 आहे तो पहा, डी बाय डी एक्स ऑफ, जर कॉन्स्टंट टर्म असेल तर त्याचा डेरिव्हेटिव्ह 0 असतो. कधीही लक्षात ठेवा, इन द सिस्टम ऑफ अ डेरिव्हेटिव्ह, इफ any term is a constant, then its derivative is 0. Here we conclude the result that dl bar by dt which is equals to 0. इसका मतलब क्या होता है, अगर किसी भी टर्म्स का डेरिवेटिव 0 आता है तो डेफिनेटली वी कैन से दैट दैट टर्म इज कांस्टेंट, दैट टर्म मस्ट बी कांस्टेंट. तो यहाँ पे देखो यल का डेरिवेटिव अगर आपके पास 0 आता है तो डेफिनेटली वी कैन से दैट दिस इंप्लाइज दैट यल बार विच इज इक्वल्स टू कांस्टेंट. देयरफॉर द एंगुलर मोमेंटम is conserved. Conserved means constant, and hence proved. And hence proved. अशा पद्धतीनं हा कंप्लीट थेरम होतो. हा थेरम खूप महत्वाचा आहे. काय अडचण आहे का रे स्टुडंट्स, विचारा. मी 1-2 मिनिट देतो. या 2 मिनिटामध्ये मला काय अडचण असेल तर विचारा. दिस इज व्हेरी इम्पॉर्टंट थेरम. Important, very very important theorem. See this, the statement of this theorem is, if applied torque is 0, then the total angular momentum is constant, or prove that the angular momentum L bar is constant if the total external torque NE is 0. So consider a system of a particle. It has n number of a particle having a masses m1, m2, m3, mi, mj dot 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 mn, where mi is the mass of ith particle, mj is the mass of jth particle. So we know that angular momentum is the moment of a momentum. That means the angular momentum is the cross product of ri. Suppose ri, ith particle, ri and pi. Ri means the position vector of ith particle, pi means the linear momentum of ith particle. So angular momentum is equals to angular moment of a total system. So we have to take the summation over I, ri cross pi. So pi means mi into vi. याला सॉल्व केला, परत हे टर्म घेतला, परत इथं डेरिव्हेटिव्ह घेतला, डेरिव्हेटिव्ह घेतल्यानंतर आपल्याला लास्ट टर्म मिळाली L bar dot is equals to summation over I ri cross pi. Now we know that by the Newton's second law, pi bar dot is equals to fi bar external plus summation over j fji. So put this value in this equation. So then we get the result. In the equation 3, the second factor goes to 0 by using the Newton's third law. Total internal force is 0. So we get the relation L bar dot is equals to summation over I ri bar cross fie external. We know that. Now move towards the torque. We know that the applied torque on the system of a particle is given by N bar external is equals to summation over I ri cross fi external. From the equation 4 and 5, L bar dot is equals to n bar external. So dr bar by dt is equals to n bar external. But according to the given statement of the theorem, total external force is 0. That is total external torque is 0. Therefore n bar external is equals to 0. Put in equation 6, dl bar by dt is equals to 0. The derivative of some term, derivative of any term goes to 0, then definitely we can say that that term must be constant. So dl bar by dt is equals to 0. इसका मतलब होता है dl का डेरिवेटिव अगर 0 है तो L must be constant, so L bar is constant. L bar means the total angular momentum is constant or conserved and hence proved. अशा पद्धतीनं हा थेरम इथं संपतो. आता जो नवीन बीट आहे, कन्स्ट्रेंट्सचा जो नवीन बीट आहे, तो नवीन बीट आपण उद्याला सुरुवात करू. आज इथं आपण थांबू. नमस्कार, गुड बाय. सर्व विद्यार्थ्यांनी परत एकदा सूचना आहे रे, सर्व विद्यार्थ्यांनी एकदा अटेंडन्स टाका. मी तुमची अटेंडन्स नोट करून घेतो. हां चला रे, टाका सर्वांनी अटेंडन्स टाका. हे सर्व एक्सटर्नल इंटरनलचे अटेंडन्स. सर्व जे एक्सटर्नल आणि इंटरनल फोर्सेस आहेत, हा दोन थेरम महत्त्वाचे थेरम आहेत, लक्षात घ्या. दोन्ही थेरम तुम्हाला समजले पाहिजेत, करता आले पाहिजेत. टोटल अँग्युलर मोमेंटम, इफ टॉर्क एक्सटर्नल टॉर्क इज 0 देन टोटल अँग्युलर मोमेंटम इज कन्झर्व्ड. सी दिस, टोटल अँग्युलर मोमेंटम इज कन्झर्व्ड. आणि काल जो आपण थेरम पाहिलेला आहे, conservation theorem of linear momentum of the force, if total external force is 0, in the last lecture we have seen, the total angular momentum is 0